Okay, here we go. Yesterday we talked about the role of the role of A in y equals ax squared plus bx plus c. Just really quickly, remember we looked at a graph yesterday to figure that out. So can somebody give me a little descriptor of what A does? Remember we changed it, we had this graph. Let me pull this graph up. We had this graph and we changed it around. Kendra? Good. Okay, so the bigger the number A is, the absolute value of A is, the more narrow it is, and conversely, the smaller A is, the wider the parabola is. Marcy?
If it's positive, it faces upward, and if it's negative, it turns into a down.
Good. Okay, so if it's positive, it opens up, and if it's negative, it opens down. Okay, so today we're going to look at C. So C is the one that is on the very end. That doesn't have any x's attached to it, so you can see up here it's at the very end. So right here we have y equals 1x squared plus 0x plus 0, which is the same thing as just y equals x squared. So let's take a couple of guesses here. Can anybody guess if I change this from y equals x squared to y equals x squared plus 3? What do we think is going to happen to the graph? Any ideas? Kendra? Get what? Okay, maybe it'll get wider, or what? Or, okay. Jared?
The vertex will be higher.
The vertex might be higher, okay. Have an idea how many higher? 3. Okay, any other ideas? Okay, so let's try it. So the vertex right now is at 0, 0. So if we change it to 3, so it's y equals x squared plus 3, the vertex shifted up 3. So do you think that if we made it y equals x squared, let's go back to 0. If we made it y equals x squared minus 6, do you think it's going to shift down 6 units? Okay, let's try it. Let's see. Okay, good. So it shifts down 6. So we can also, if we play around with some of the numbers in B, it basically, the role of C is to shift the graph up and down. Okay, so let's fill that in over here. So the role of C is it shifts the graph, or the parabola, up or down. So depending on what the value of C is to start out with and how many you add to or subtract from it, it's going to shift up or down the same number of units. Okay, anything else about C that might be valuable to us? Yeah, Marcy?
Is that the vertex?
It's not necessarily the vertex, but here, let's check something else out on this. So right now, so we noticed that if we changed C to -6, we then went down to -6. And just like if we did 3, then it's up here at 3.
Or did just where the vertex?
Not necessarily. Okay, so let's do this. Let's change that. Okay. Now, that is now x squared plus 5x plus 3. Does anybody see anywhere on this graph where that positive 3 still comes into play? Where? What? Someone come up and point to that. Wherever they see that 3. Come up to the screen and actually point to it. So she's pointing right here. So that's like -1, 2, 3, 4.5.
And it goes 3 right here.
Okay, maybe this distance. Anyone see it anywhere else? Jade? Oh, where? Here? Oh, right here?
Yeah.
So 3 up?
Yeah.
Okay. Anyone see it anywhere else? Jade?
The other side?
The other side over here? Good. So that one's kind of interesting. Well, interesting. Let's be honest, it's not necessarily interesting, but it's there. There are 3, it's 3 units up. So what if we change this now to a 7? Anybody see it now somewhere? Just notice that we were pointing out these distances before. Is that 7 units?
I don't know where I have no idea. Yeah.
Okay, does everybody see that this is the y-axis right here?
Yeah.
And where is the graph crossing the y-axis? At 7. What is it called again? What is it called again when it crosses the y-axis? The y-intercept. So the y-intercept also represents c. So like if I make this -2, then you can see that the y-intercept is at -2. Okay, so that's another piece of this, is that it shifts the graph up and down, and then c is also the y-intercept of the graph. Okay, so nobody write this next example down, okay? Let's see if we can, let's do an experiment today. Nobody write anything down from this point on. You can write the roll, whatever, but just watch the next examples, okay? I want to see if this makes any difference for us. Okay, so I notice sometimes people are like furiously copying down the notes and then not paying attention. So, all right, so what we have here is we have the graph of x squared plus y equals x squared plus 3x. We are being asked to sketch the graph of g of x, but g of x is f of x plus 3. Okay, so if this is the graph of f of x, and you all just told me that if I change my c value plus 3, it shifts the graph where? Up 3. So can anybody make a guess as to what we can do with each of these points if it's saying that our new graph from over here should be the old one plus 3? What's going to happen to all of the points that we have on here? They're all going to shift up 3. So 1, 2, 3, there's our new point. 1, 2, 3, new point. 1, 2, 3, there, and there. Okay, so this is the graph of g of x, which is f of x plus 3. Okay, questions on that? Okay, so the next piece of this is, that would be a fun experiment. We should try, because only on accelerated algebra 2, to like not take notes for the rest of the semester, you guys, and then see how that works. Some of us,
on the final.
not necessarily though, because you still have to write down your homework. But okay, anyway, whatever. We can talk about that later. All right. So we have up here that f of x equals x squared plus 3x. The second piece of this is saying write an equation that defines g of x. Well, if g of x equals f of x plus 3, and f of x is x squared plus 3x, all we're going to do is replace what f of x is equivalent to into this expression right here. So x squared plus 3x, and then there's that plus 3 on the ends. Okay? Questions, Marcy?
When you did the whole f of x equals x squared plus 3x, I don't...
That was given to us. All of the information, so this graph was given to us and everything.
Yeah, but it's just that I understand where the 3x is coming from, but I don't really understand how it got that shape necessarily. So what does the x squared do in the formation of your parabola?
Okay, so remember we spent the first day, the first very painful day of notes in this particular unit, making tables.
Yeah.
Okay, if we were to make a table and plug in 1 into this expression, we would get 4. If we, and again, 0, 0. So that's the shape that comes out of this graph.
Oh.
We also learned a trick yesterday to graph it, but does that answer your question? Yeah. Okay, other questions? Okay, so that's the first part. Next, keep in mind that c is also the y-intercept. Okay, find the y-intercept of the graph of each function. So this first one, y equals x squared, 8x squared minus 5x plus 7. What is the y-intercept here? 7. Do not overcomplicate. Questions? Second one, what's the y? Yeah. Okay, Akashni? -6, good. Shh, nobody should be talking or whispering. Okay, other questions on this? Last one, or fake whispering. Okay, next one. The vertex of the graph of f of x equals, this is the last one, it's very, very short. Yay for short notes. The vertex of the graph of f of x equals this expression is at -2, 11. Okay, so we're going to use that to find the vertex of this next one. Determine the coordinates of the vertex of the graph of g of x when g of x equals 2x squared minus 8x minus 2. So what I'm hoping we all notice is that with these equations, everything is exactly the same except that. Does everybody notice that? Okay, So to get from positive 3 to negative 2, you have to minus 5. So positive 3 minus 5 is 2. Well, if the C represents how many units up or down, y coordinates are the ones that go up or down. So we take that negative 5 and we subtract it from the y coordinate of the vertex. So our new coordinate is negative 2, and then 11 minus 5 is 6. Does that make sense to everybody? Does that make sense to everybody? Yes. Okay, so if we use that same concept with the last example up here, same functions to start out with, except how many am I adding to the y coordinate in this one? Kendra? Plus 2. How'd you get that? 3 plus 2 is 5. So then our new coordinate for our new vertex is what? Ashley R? Negative 2, 13. Excellent. Okay, any questions? That's about what your homework looks like. Marcy?
It says, one of the question, it says write the equation that defines.
Yeah, so remember we did that. That was this one, the second piece of it. In this first example, okay. Okay, other questions? Okay, so everybody go ahead and start on your assignment.